Hello. Let me get my thing. What's a click blue button? It says, what is this? Oops. Okay, seriously. Huh? What are you guys complaining? Let's see. Obvious. SMPT told us would be fun. I'm not having fun. Did you solve it though? Maybe. By the way, Keith, direct message doesn't work in this class because I want to keep the chat on there. So when you come back and see it, you know what people are complaining. Actually, infinite Pokemon meetings. Aha! Actually, that's smart. Just prove that pattern. Okay. The hint is really just to modulo 3, then you see a pattern as you play the game. How do you prove the pattern? Prove that your move are going to contain in the pattern, right? If you start in some set of patterns, you're going to end up with the same set of patterns. Then you know that you're not going anywhere. Okay, blah, 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 blah. Have your TA take a look. That works too. Blah, blah, blah. People ask me some random question again. Okay. Before you hate Pokemon, there's a new Pokemon for Switch, right? I don't remember what it's called, but there's a new Pokemon game for Switch. Today, what we're gonna learn is more recurrent. It's called linear recurrence. If we have time, we're gonna do some divide and conquer. Okay, but to remind you, homework for due tonight. Homework 5, very easy. Due to you're not sharing the screen. Thank you. Thank you very much. Okay, now. Yeah, I know you missed me. Maybe Airbus. Okay, homework 5. Easy. This thing is easy. Easier than usual, like very easy. Okay, so for Pokemon, you want to do the eventually I'm just going to give you a vague hint, right? When you do modulo by 3, okay, you're going to see that you're going to end up with a certain pattern, right? There are 3 things that you can end up with. I think if I remember correctly, there are 3 things that you can end up with. And each one of them, when you do, is going to switch around. Okay, so your whole proof is to show that you are still in that set, right? Okay, so what you want to show is to show that if you're in blue set, your move, whatever you do, you end up in blue. This is what you want to show for Pokemon. That's a weak hint. Right, you're gonna end up on itself. You're gonna end up on itself. That's it. You know what I'm talking about, right? I suggest you play the game, then you'll see. Justin is like lazily smart, so he used Python to play the game, which works too. Right. Lazy is a good quality. It's not a bad quality, by the way. Lazy is a really good quality. There are people who think the more effort you put in, the more output you get. No, no. You should be lazy. I expect all my students to be lazy, but hand in the homework though. Okay, so let's learn what we try to do. Oh, by the way, there's a midterm, right? Midterm is 1 week after homework 5. Midterm is the week after homework 5 handed, right? The week after homework 5 handed in. I don't remember the date, which is like next week. Okay, handed in, and it's going to be open book, open notes, open notes. Okay, and all I ask you is don't do something stupid like, so for example, you post the question on Stack Overflow or on Check or whatever, you know, it's very easy to trace back. So if you do that already, then you know it was a dumb idea. So please don't do anything stupid. That's all I ask. If you did that already, just confess. It's really easy to trace back. Okay, so open book, open notes, and you have like a lot of time to lessen your stress. I trust you not to do something stupid. So please don't do something stupid. Okay. So let's say no communication to outsider. That's all I ask. No communication regarding exam. Alien is considered an outsider. So don't, even though you're gonna waste your time though. Can you be my tutor? No, that's called an outsider. Person that is not you. To any communicable living thing that is not you. You can talk to yourself if you like. Any living organism, including your cat, Saran. Living things except you. Okay. You can talk to a tree. Yes, you can. Right? Don't like something as stupid as ask it online, get someone to help. Yesterday, I look at the economics of like, you know, there's a group people whom you can hire to do the homework. The economy is so bad, especially in Thailand. They charge like 2 baht per page, or maybe 50 cents per page when the demand is fall. It's actually follow the economics and so on. It's sad. Just don't do it. Like I said, this class is about you to learn. Okay, so let's get back to our thing. Our thing is today is about linear recurrence. So the problem is the following. You have a stairs. Oh, and 5 steps, right? 1, 2, 3, 4, 5. Okay. And you want to figure out the way to walk upstairs. And you say, Ajahn, there's only one way. No. Because I know some of you, if you have a long leg, here's what you're going to do. You're going to hop, right? Actually, let me change the color. 2 seconds. Color changing. Okay, magic. You're going to hop, step, and hop. We get? Right? So that means each time you do it, you have the choice of hopping 2 step, right? Hop 2 step, or walk 1 step. Okay, so the question here is, how many ways are there to walk up 5 steps? We're gonna learn about counting maybe next time. How many ways to walk up 5, which you know we're gonna change it to n later step. What do you think? 3? Why 3? No. I can tell you there are a lot more than 3. So for example, you can step 5 times, right? You can step 5 times. That's clear, right? You just walk 1 step at a time, 5 times, and you get what you need. No, not 5, choose 1. It's much more complicated than that. Or you can hop, and then step, right? Double hop and then step. Okay. Or you can hop, step, then hop. That works too. That's what I just drew. If that's good. Or you can hop and then step, right? That's all it includes. We get, right? And then you can do the step and then maybe, I don't know, a hop, 1, 2, that's 3, plus step, right? S, H, step, hop, that works too. Or step, hop, step. You know, there are a lot of them. Not 3, not 5, choose 1. Okay. I'll get. Any questions so far though? Everyone understand the question, right? I want to know how to do this. Okay, and you know, when we talk about recurrence, you want to use your friend. How would we use our friend? Here's a question, really. If you want to count the number of ways to walk up 5 steps, how would you use your friend? What do you think? And I explain the question again. Yes, you have the stair of 5 steps, right? When you go up the stair, you want to complete there. You want to complete the 5 steps. Okay. Each time you do it, right, you have 2 choices between hopping 2 steps or walk 1 step. So that means you can walk, you can hop 2 steps. Now you end up on stair number 2, and then you can step, you end up on stair number 3, and then you can hop. So that would be this guy, right? Hop, step, hop. Okay, good. Now what said? And we want to count the number of ways, like how many of these are there, right? You can see that counting this is like kind of a pain. You could list them all though, but it's a pain. Can we only use 1 step? Okay, good. You can use 1 step if you like, right? So that's how you go from 2 to 3. But you want to complete the stair, so that means you need to add up to 5. Okay, so now what said? We find out how many ways to do 4 steps. What would you do to find out how many ways you do like smaller problem? How would you solve smaller problem in the last few weeks? What do we do? Friend neighbor, good, right? So good. We have a lot of friends, right? You have T4, people who know how to like the number of ways to walk 4 steps. We have T3, the number of ways to walk 3. We have T2. We have all the friends you need, but you do not have T5. T5 is what you need. right? It really means the same function, but you put in a smaller argument. Okay, so how does having friend help us count? Right, right. Friends mean the function with lower number of argument, with smaller argument. What do you think? Anyone? Anyone? How do we count this systematically? That's a real question. How do we count this systematically? Start with one. What happens? So you can okay, good. Keith suggests something interesting. Keith say, okay, Ajahn, I think the way that you write this, right? Actually, let me move. Oops, sorry. Let me move this guy a little bit. The way that I write this, you can see, right? You're so close, Keith. You are so close, except you start thinking about doing the job that your friend should do. If you start thinking about doing the job that your friend should do, you should stop. Okay, so think about this. Think about this. The way I write this. Think about this. There are only two ways to walk upstairs. There are only two ways, right? You two categories. Let's say two groups. One group, you start with hop. You start with hop. That means you walk two steps, or you start with walk. Okay, right? So that means depending on the first step, you can separate things into two groups, right? And then there's no intersection, so you can add them easily. Okay, so let me ask you, if you start with hop, okay, like this guy, if you start with hop, then how many ways are there? How many ways are there to start with hop? What do you think? You start with hop. Hop means you walk to you jump to step. Or do you think you can get your friend to do this? That's a real question. The real question is, can you get your friend to do this? What's the question left that you need to do? If you want to count the number of ways that you start with hop, very good, right? You have 3 steps left. What would you do? You're not going to count yourself. You're going to ask your friend, okay, Mr. Tree, how many ways are there? Right? So this thing is hop first, right? The number of ways that you hop first. Wait, is that Mr. Tree in hop in one piece? I don't know. I stopped reading for a while. I wait until he get off an island before I actually read the whole thing. Okay, T5 is T3. Everyone is good with this, right? If you hop first, that means you have 3 steps left to do. So that means the number of ways that you hop first is exactly the number of ways you walk up 3 steps up the stairs. That's why you do not count it yourself. You use your friend number 3 to do it. Okay? Any questions so far though? This is very important point. Okay, so how about this question? How about this question? If you start with a walk, that means this is what happened, right? This is what happened. You walk up one step. How many ways are there? How many ways are there? If you start with walk, how many ways are there? 4 steps left. So how would you count? Which friend would you pick? Very good. So you pick plus T4. Good. Everyone get? Right? So that means the number of ways to walk up 5 stairs is the number of ways to walk up 3 stairs plus 4 stairs. Does this thing look familiar though? If you did the homework already. It's a Fibonacci sequences. Okay. I don't know, maybe double B, I don't know, Fibonacci sequences. It shows up everywhere. It shows up everywhere. Are we good? Right? So you know that this is not your answer yet, right? It doesn't give you any number. It doesn't give you any number. What do you need? What do you need? Tell me. If you do the homework already, what do you need? At least you guys should start like the first problem. Okay. Wrong induction. No. Remember when you do Fibonacci, right? You need something else as well. Like, so for example, if I asked you to find T5 as a number, you can't, right? You really can't. But you know that if you have friend number 3 and friend number 4, you can. So what you need is the base cases, right? So that means let's do the easy one, like T1 and T2 or something, right? T1 is how many ways to walk up one stair? 1. What about T2? It's 2, right? It's either step or hop. That's all. And then now you know you can generate all the rest, right? Like, so for example, T3, that is going to be what, 3, right? Because it's T2 plus T1, and T4 is going to be 5. So T5 is going to be 8, and so on. Are we good? Okay. So this kind of thing, this kind of equation is called linear. Actually, let's get the full name. Linear homogeneous recurrence. Okay. Linear homogeneous recurrence. That you don't really care, right? The name. In this class, the name is like the least important thing. What is homogeneous and what is linear? Okay, good. I'll explain that. So let me write it in a more general form. Okay. So typically you do something like this, right? Tn is Tn minus 1 plus Tn minus 2. Okay. So if you are a mathematician, typically you don't write like this. Well, maybe some do, but the way that people write it is this. It's 0 is Tn minus 1 plus Tn minus 2 minus Tn. Okay, they do it like this. Or maybe if you are an OCD, you want to sort this thing by the increasing order. Wait 2 seconds. Okay, minus Tn or minus 1 times Tn plus this. Okay, that works too. That's 0, right? I just moved this guy. And this 0. So when you have something that add up to 0, a linear thing that add up to 0, that 0, I mean, is homogeneous. That means they do not add up to 1 or anything, right? The whole bunch of function. This is actually related to ODE, by the way. You can think about Tn as like second derivative, third derivative, and so on. Tn is like nth derivative. That works too. So when you see linear homogeneous equation in ODE, that's the same thing. The homogeneous just means that's 0. Okay? Because the fact that it's 0, you're gonna see later today that it has so many properties. It has so many nice properties that you can do. Okay. The next thing is, so you may ask, okay, Ajahn, why it is linear? Because there is no Tn square, right? Everything is a linear combination. A linear combination means the following is some constant. So in this case, it's minus 1 times the function itself at n, right? It's not t square n. It's just t of n. It's not sine of Tn. So it's linear plus T1 times Tn minus 1 plus Tn minus 2. Okay, that's 1. So this is the fact that it's linear. That's why it's called linear homogeneous recurrent. So when you see it in ODE, so for example, most of the second order ODE that you're gonna learn So for example, for risky, it's a spring equation. It's a linear equation. It's when you do not have the left side, that's the linear homogeneous one. Okay. Any questions so far though? What we want to do today, we want to figure out how to solve this. What's the sign in front of OGTN? What is OGTN? That one, -1? -1, right? Because that's, I want to show you that it's some constant times that. Okay? Today, we want to solve them. Okay, and we will get rid of the mystery of 1 plus square root 5 over 2, because we know if you did homework, that 1 plus square root 5 over 2 is kind of surprising, right? Something that looks as simple as this somehow has to do with the golden ratio 1 plus square root 5 over 2. Okay, it's kind of surprising, like where does square root 5 come from? Why does it work out so nicely? It's not something like you dream up every day. And yes, people do not dream up with 1 plus square root 5 over 2. They do something really smart about it. Okay, so here's what we want to do. Let's solve something without the square root 5, because otherwise it's going to bog down by the detail. Let's solve something easier, which I prepared a number already. 2 seconds, let me find my number. Where's my number? Wait. The number is, 2 seconds, is t of n is -2, t of n -1 plus 2t. Yes, I'll share the screen in a second. Let me copy the question. I want to make sure that it's some sort of at least a rational number. So t0 is 1 and t1 is 2. Okay, now we can get that. Okay, let's try to solve something similar. You may think, Ajahn, this looks more complicated because you have -2 and 15 and so on. Trust me. This actually makes things so much easier than that thing, because the answer to that thing is like square root 5 and so on. Okay, so we want to find exactly what is t of n, right? We want to find the closed form of this. That means I want to know, like, is this guy like 2n squared plus 3n cubed plus 4 or something? Some closed form that you don't have to for loop to do it. Okay, that's what we wanted to. Okay, so the first thing that we should do, let's plug in some number, and maybe you can stare at it and then you can tell me what's the formula, right? T0 is 1. Sometimes I put it here as a suffix because to save some space. I really need a lot of space for this one. T1 is 2, and T2, right, is going to be -2 T1 plus 15 T0, which is -4 plus 15, which is 11. Okay, T3 is -2 T2 plus 15 T2, oh, T3, right, which is, oh, not 3, 3, 1, and then that is -22 plus 30, which is 8. T4 is -2 T3 plus 15 T2, which is -16 plus 15 times 11. That's a big number. I can't do it in my head. Maybe I can. It's 165, which is, I don't know. Wait a second. I might have that number already. And I don't. Good. Let me do that real quick, which is what? 149, right? 149. Okay, now let's see. You look at these sequences. Can you tell me the formula? 1, 2, 11, 8, and 149. Last time, who was it though? Karit, right? Karit, you said the number and you tell me what's the, where 15 come from? Come from here. 15 comes from there. Go Karit. Yes, you are like ความหวัง of หมู่บ้าน You are everyone's hope. I think you gave up, right, Karit? Last time Karit had a number and he magically come up with a solution, which is good. But for this one, I think it's really hard. I don't know, maybe Karit is really smart and figure out by staring at it. You understand me, Taiwan? Okay, let's pretend Karit get a debuff. So he is like 90% dumber than usual. Okay, so his intellect is minus 90%. He got a debuff. So he cannot figure out what the pattern is. So we're gonna do something interesting. Okay. So here's the way we do it. So watch carefully though. It's like dark magic. It's like dark magic. Okay, let's look at this. This is what we do. When we have no idea what to do, this is what we're gonna do. We are going to guess the answer. Okay, we are going to guess the answer. And because it goes up really fast, right? This thing, if you try to plot this, it goes up to like 149 really quickly, right? So we should get something along the line of exponential, right? We should get something along the line of exponential, which is actually is what you should always guess. If you see ODE before, then you know what I'm talking about, like risky, you know, we guess the solution like sine, cosine, and somehow they magically add up. So we're gonna guess the answer of the following form. Okay, this is a guess. Okay, this is a guess that what's that called? That T of n, okay, is a to the n for some real number a. Okay, so we are not guessing one solution. We are guessing the family of the solution, right? We are guessing that okay, some number raised to the power n should solve this. Okay, this is a key. We are not guessing one solution. We are guessing a whole bunch of solutions, right? But we know at least one of them should work, right? We hope that at least one of them should work. Is someone good? This is our guess. Total guess. No reason why you should guess that, but you should always guess this. Maybe the only reason is because I tell you, please guess this one. Don't guess something else. I'll make sure that this guess works. Okay? Well, you graduate from Hogwarts? No, I graduated from Caltech. Which is like Hogwarts, except technology. Which they do something so magical that I have no idea how to do it. So it's like Hogwarts, except technology, except science. Okay, so let's do this. Let's do this. We are not guessing one answer, right? We're guessing a whole bunch of answers. But we know if this thing is going to work, when you plug in the top equation, if it's gonna work, right? When you plug in the top equation, it should satisfy the top equation. Okay, this is a key idea, right? If it works, if a to the k works for some number k, for some, if a to the n works for some number a, then if you plug it to the top equation, then it should satisfy the equation. Okay, so let's plug it in. Let's plug it in. So it says the following. I plug this thing in. It's gonna give me a to the n, right? It's tn. A to the n is minus 2, a to the n minus 1, plus 15, a to the n minus 2. Right? That'd be good. What's so tempting to do? Can anyone tell me what's so tempting to do? And why is this useful? Let's think about this. Let's think about first. Why is it useful to do this? Maybe you see it after you cancel out a whole bunch of things. Bring something else. Just tell me what cancel out. Make them the same power. What cancel out? Just tell me what cancel out. What should I do to both sides? Very good. We should divide by a to the n, both sides, right? And now you're going to see the magic. It's going to be 1 is minus 2, a to the minus 1, plus 15, a to the minus 2. So the magic here is the following. N is gone, right? N is gone. So this is the equation for A. You can solve for A. And why would you want to solve for A? Because if you got an A that can do this, that can do just this, it means that that A, so suppose you found that it's number 3. I don't know if 3 works. Okay, let's say you found out that somehow A is 3 because you can solve this. Let's say you found that A is 3. What that implies is very important. It implies that Tn equals 3 to the n works. Let me put a quote. You'll see why. Is everyone good? Before we do the algebra, I want you to see the big picture that if we solve for A and A comes out to be 3, which I don't know if it is, right? That means 3 to the n works. That means we find at least one solution. Is everyone good? Any questions so far? Though? This is a very important point. I want to pause here a little bit before we do the algebra. Okay. Okay, let me try to explain it again, right? We guess at the beginning, we guess Tn is A to the n. But if A to the n were to work, that means if I plug in this guess for Tn, it should satisfy, make the left-hand side and the right-hand side equal, right? It should make the left and the right-hand side equal. So that's what we do. And we solve that, okay, if A is 3, right? If A is 3, then it is at least it makes the left and the right-hand side equal. So that means 3n is equals to 3 to the n works. Okay. 3 may not be the real number. Actually, that is a good reason why you would expect it to grow exponentially. Because if you think about it, it's piling up, right? If you try to expand this like T100, right? Then you get T99 plus T98. And then you get, and each one of them expanding into 2. So you expect some exponential amount of terms, right? So think about this. You kind of doubling it every single term, right? Every time, because you kind of doubling the number of terms every time. So you would expect it to grow exponentially somewhat. So this is the guess. Okay, we get, but really just guess this guy. Just guess this guy, but really just guess this guy. Some guess actually come from physics. I think if at the end you're gonna see that this is actually second order linear homogeneous equation, second order ODE. For those of you who take ODE and have exam next week. Okay, so let's solve this. Let's solve this guy. Let's solve this guy for A for real. I'm not sure if it's 3 or not, but okay. So what should I do to solve this? What should I do? What's so tempting to do to solve this? But now you know the reason we solve this is because we want to find the A that works. What do we do with all the A's? I hate the -1, -2 so badly. What do you do? What do you do to both sides to get rid of A to the -1 and A to the -2? Square? No. You get yourself into more trouble. If you square it, right, then you're gonna get A to the -4. Good. You multiply by A squared on both sides, right? So it's gonna be A squared is -2A plus 15, which looks familiar. Let me write it in a more familiar form. It's A to the second plus 2A minus 15 equal to 0. Can you solve for A? Yes, you can, right? Let me just write it down because I know you know how to do it. Did I screw up the sign though? I did not, right? Just to make sure that I did not screw up the sign. So A minus 3 and A plus 5 equal to 0. Which means, exactly, this is ODE, characteristic equation. Yes, there is a real connection between this guy and ODE, right? You can think about Tn as like the n derivative, as I said before. Yes, this is the characteristic equation. Very good for you to notice that though. อาจารย์ who's teaching it though? อาจารย์เอก or อาจารย์แจ็ค he's going to be proud that you actually notice that this is a characteristic equation. Risky, I expect you to see that this is characteristic equation. I'm kidding. So let's do this. Let's do this. So it means what? Can you explain characteristic equation? Is this exactly what we just did? There is a way to transform ordinary differential equation into algebraic equation. And the method is called Fourier transform, which random Indian guy on YouTube can teach you on that one. There's a way to turn it into characteristic equation. Okay, and then you solve the algebra, you solve the characteristic equation, then you get a whole bunch more clues on how to solve the problem. Okay, so in this case, we have two things, right? We have, let me call, I don't know, what should I call? Let me make sure that I match it with the lecture note. What do I call it? F and G, good. Okay, F of n You know, I made this number to make sure it's an integer, and two smallest integer that doesn't look too trivial are 3 and 5. So I guess that if I made up the question, you can expect small number, small integer because I'm lazy. Okay, f of n is 3 to the n, and g of n is 5 to the n. Wait, not 5 to the n, minus 5 to the n, sorry. Minus 5 to the n. So this thing is a is 3 and minus 5. Okay, so now we have two functions that we claim to work. Let's make sure that it actually works. Let's make sure it actually works. It's actually guaranteed though, by the way you do it. You can actually do this in reverse. So let me show you that it works. By the way, when it works, it means the following: that 3 to the n is minus 2, 3 to the n minus 1, plus 15, 3 to the n minus 2. Okay, let's put a question mark here. I claim that the right-hand side, okay, I claim that the right-hand side and the left-hand side are equal. So let's do the right-hand side. We hope that it's going to cancel out to 3 to the n, right? So you have what? You have minus 2/3, 3 to the n, right? Plus 15 over 9, 3 to the n. And if you add them up, what do you get? You're going to get exactly 9 over 9, right? If you do the thing, 9 over 9, 3 to the n, which is 3 to the n. At least we know that this guy, right? This guy satisfies this. You can do the same thing for minus 5. You're going to get this. Satisfying this. But someone said, is that one good, right? F and G, at least it solved the top one. At least we know it solved the top one. Right? You can plug it back, but actually the way that we did it, we can actually do everything backward. So it's sort of guaranteed that whatever you solve will do the job. Okay? Is there any question though? Is there any question regarding this? That F and G, at least it solved the top one. Are we good? Everyone with me so far, right? So we know we have two candidates. The question is which one? Right? There should be one answer. It should be one answer. Which one? Which one do you want? F or G? Let me erase this. F or G? Which one do you want? Can the answer? Do you want 3 to the n? Why is that? Why do you not like minus 5 to the n? Which one would you like? Would you like F or would you like G? Well, F is not your grade, by the way. Don't get an F in this class. Would you like F or G? yes, this is not exactly about the staircase. I just want you to see that a similar equation can be solved, which we're going to come back to the staircase later because staircase has square root 5 everywhere and then it's going to confuse you like crazy. At least this thing. Would you like 3 to the n or minus 5 to the n as your answer for this recurrence? 3 to the n. Why? I like you to be positive. What would you check though? What would you check? What would you check? What would you compare? Or a lot of people didn't say anything. Is that a problem with these two answers? Is that a problem? Real, they both real number. They are both real number. What's the problem? What's the problem? Really, the question is really yes. No, that's fine. Alternate between positive and negative, but that's not a problem, right? What exactly is the problem with 3 to the n and minus 5 to the n? What exactly is the problem? What exactly is the problem? There are two solutions. Yeah, that there should be only one, right? But if there are two, you should pick one. But if you don't want to pick any one, then tell me why you don't pick any one of these. Very good. Because of this guy. Not only, if you want to find a solution, right? Not only that it has to satisfy the equation on the top, not only that it has to satisfy the recurrence, it has to satisfy the boundary condition, or some people call it initial condition, right? So that means this function, if it were a solution, right? When you plug in n equal to 0, it should give you 1. When you plug in n equals to 1, it should give you 2. But neither of these, neither of f or g, give you t1, the right thing, right? Because f1, right? f1 is 3, g1 is even worse, is minus 5. None of these match with this guy. Okay, now we are in trouble, right? Because then you guess it and you just pick a bad guess. It's actually every guess there is. Everyone get? Right? Is everyone get that? That is a problem. That neither F or G is what we need. Okay? Because not only that you need to satisfy the top equation over here, not only that you need to satisfy the recurrence, your solution need to satisfy this guy, the initial condition, right? Not only that it has to satisfy the recurrence, you need to be able to plug in t0 equals to 1, which both of them do, and t1 equals to 2, which neither of them do. So neither of them is a solution. Okay, so far so good. We are sort of stuck, right? We're sort of stuck. Anyone pay attention in ODE though? Do you know what to do next? Or risky? Anyone pay attention in ODE? What do you do next? You have a whole bunch of solutions, except it doesn't fit the boundary condition. What do you do? Do you just change the boundary condition? This is not like politics, right? You hate the election, you change the rule so that you have like Senate, 200 Senate to vote for you. No, no. Aha, Hanasat said, write a general solution and solve for the initial value problem. Good, we're gonna do exactly that, except in recurrence term. But what we did is going to be very similar to what you do in ODE. So let me explain what we're gonna do, okay? So let me show you two properties. Let me show you two properties, okay? Let's say if you have two linear homogeneous equation, okay? Let me say if you have two linear homogeneous equation, I'm not gonna prove it though, but you see the proof is like 3 lines, okay? That means A Tn plus B Tn minus 1 plus C T of n minus 2 and so on. Okay, let me claim the following. Let me claim the following, that f of n solves the top, solve the recurrence. Okay, and g of n also solves the recurrence. Okay, what that means by solves, that means it's like 3 to the n and minus 5 to the n. That means when you plug it to on the right hand side, when you plug f of n on the right hand side, everything magically cancel. Right? Everything magically cancel. So that's good. Okay, so this thing you can think about it as like your 3 to the n, and this thing is like minus 5 to the n. Right? Let's say you have two solutions. So that means, let me just write it. 0 is a fn plus b f of n minus. Let me be more explicit so you see what I meant. Otherwise, you're going to get so confused. I try to make the notation less confusing. Okay? By solves, I mean if you plug it in on the right hand side, it's going to be 0. That's what I meant. Right? This is what happened to 3 to the n and minus 5 to the n. Let me ask you something about this guy. What do you know about 5fn? What do you know about it? Let's call this thing h of n equals 5hfn. What do we know about it? If I multiply a constant to a solution, what happens? You can still pull it out. Okay, so let's do exactly what one of us suggests. So let's see, if I plug this guy, h of n, in here, what do I get? Right? So I'm going to get the right hand side, right? Only the right hand side. Right? The right hand side is going to be a times 5fn plus b times 5 f of n minus 1 plus c times 5 of f of n minus 2 plus dot dot dot. And what's so tempting to do? Like now what said, you're going to pull out the 5, right? You're going to have 5 and then a of fn plus what? b f of n minus 1 plus c f of n minus 2. Okay, so far so good. And so on. What do we know about this? What do we know about this? It is 0. Why is it risky? Why is it? Why do we know it's 0? Very good. It's from the fact that fn is a solution. So that means if you plug it in, it's going to be 0. So this thing is 0. Okay. So that means if you plug in h of n to that guy, right, it still is a solution. So now you learn one very important fact, right? That if you multiply a solution by a constant, you still get a solution. Okay. So the first fact that you learn, if f of n is a solution, c, some constant, times f of n is also a solution. Okay, so far so good. This is actually very powerful. This is actually very powerful because when you get your answer, right, 3 to the n, oh, Ajahn, I have one answer. That means I can generate a whole bunch of other answers. Right? So that means if you know that 3 to the n is a solution, right? So that means, Ajahn, okay, 2 times 3 to the n is also the answer. Pi times 3 to the n is also the answer. Or maybe, I don't know, negative 2.7, 3 to the n is also an answer. Are we get? Right? Yes, that's why I say this thing is really and the fact that it works is this guy is the fact that it's homogeneous. That's zero, right? If this guy were not zero, then you can't do that magic. Okay. The fact that it's homogeneous allows you to do this. That zero is important. Okay, so far so good, right? If you have one solution, you have infinite number of solutions. But if you think about it, no, you cannot do it because if you multiply any number, like so, for example, 3 to the n, if you want to multiply by some number to fit the two, you cannot do it, right? So you may think, oh, Ajahn, that's easy, right? Because last time you get 3 instead of 2, maybe I'm going to multiply that by 2/3, but when you multiply that by 2/3, you screw up the first one. You screw up the first one. So no, we need to do something else as well. Okay, but at least you should have some hope, right? Okay, Ajahn, I can generate infinite number of solutions from one solution, which is really cool. Okay, so the next thing, what about this? Another one. What about F? What about if A, B, C, D, F, G, H, I, J, K, K, L, M, N, O, P? Okay, P is good one. P of n is F of n plus G of n. Okay, let's consider another function, which is the sum of the two solutions. Now, for those of you who take ODE, it sounds familiar, right? This sounds familiar, right? If you take two solutions, add them up, and let's plug it back in here. Let's plug it back in here and see what you got. Okay, let's look at the right-hand side. Okay, so the right-hand side is going to look like A, F of n plus G of n. We prove that F of n. No, we prove that if F of n is a solution to linear homogeneous recurrence, which is really mouthful, then any constant times F of n is also a solution to the same recurrence. The proof is actually you just rearrange my argument. That's the same thing. You just rearrange my argument a little bit. Okay. Plus b times f of n minus 1 plus g of n minus 1. Let me put in better g. And then plus c times f of n minus 2 plus g of n minus 2. Any guess on what this thing is going to be? Right, it's still out what if, and then I'm gonna conclude on what we observed. The actual proof is probably in the lecture note. F of n y over 2. What do you think this is equal to? Just tell me. Let me close this a bit. It's keep lacking on me. What do you think it's equal to? Right. Let's collect the f and g separately. Right. You see that it's af of n plus b f of n minus 1 plus c f of n minus 2, right? Plus a g of n plus b g of n minus 1 plus c g of n minus 2. And you know that both of these are 0, right? Right now you know that both of these are 0. So this thing has to be 0. So that means not only that if you can multiply any constant to it, you can add another solution to it. So that means if f and g are solution, then f plus g is also a solution. Okay, this is really powerful. And for those of you who learn ODE already, this exact same thing, this exact same phenomena happens, right? This is what someone said earlier that you solve the IVF, right? Writing a general form. Okay, this is exactly the same idea. Okay, so far so good. Any questions so far though? Any questions before I get to the punchline? Okay. Any questions so far though? You still with me, right? So what's the name of this relation? It's a mouthful. Linear homogeneous recurrence. The homogeneous refer to the magical zero you have, and linear means it's a linear, it's A, B, and C multiplied by f to the first. Okay, so it's actually differential equation that's origin of all these. So that means if you combine these two, you get what you typically call general solution, right? So you can add any constant to your solution and it's another solution. And then you can multiply a constant to your solution, it's another solution. So which means if f and g are the solution, then a times f of n plus b times g of n is also a solution to the recurrence. Okay. The origin of this is probably, I think it's ODE, is ordinary differential equation, because they probably discover, well, the guy who discovered calculus is essentially Newton, right? So ODE is around that time. So the origin of this must be ODE, but don't quote me on this. And in the chat like this, is AV any of? Yes, that's the magical thing about it. It's this guy, right? We learned that at that 5, I pick randomly. You can pick 10, you can pick pi if you like. Okay, right? Is someone good so far though? If we have 2 solutions, we have infinite number of solutions spanned by 2 numbers, A and B. And for those of you who learn linear algebra already know what I'm talking about. And as a side note, for those of you who learn linear algebra already, this thing is a vector and that thing is also another vector. Okay, and these are the components, right? X hat and Y hat. So that's why I say it's spanned by 2 numbers. So it's 2 dimension. Okay. Wait, you learn linear algebra, right? Now you learn. It's actually very useful though, but but sometimes when you learn it in an abstract form, you have no idea. What's the answer to the second? No, you need to wait for an hour for the one for square root 5. So let's come back here. Let's come back to this question. Right. We know we have a problem with the initial condition, right? That none of these does what we need. Okay, but Ajahn, it's okay because we have a hope, because we actually have infinite number of solutions. H of n is A f of n plus B T of n is a solution, which means let me just put in f of n. Do I use n? Okay, I use n. Everyone with me so far though? Everyone with me so far? Okay, everyone with me so far? Right? What do we do next though? What do we do next? What do we hope h of n would do? Right. It has to be a linear combination of the above, right? Because we know the reason that we do linear combination is because this guy is guaranteed to, and this thing gets dirty already. Okay, let me change it to green, maybe less dirty, because they say green stuff is good for you. Okay, because it's guaranteed that the linear combination of the 2 will solve the recurrence. Is guaranteed, right? That the linear combination of the solution that you have is going to solve the recurrence relation up top. So the only job that you need to do is what? The only job that you need to, what else would you hope Hn to do? It knows that it's going to solve the top for sure. What else would you hope Hn to do? The base case is very good, right? So you hope that h of 1 is going to be a has 0, right? Not 1. Sorry. h of 0, which is a plus b, right? 3 to the 0 is 1. And for what should h0 be equal to? Justin, tell me. h0 what should it be equal to? Should be equal to 1. Okay, 1 factorial is 1, so 1. And h of 1 should be, let me put it here, 3a minus 5b should be 2. Just clean this thing up. iPad doesn't like me at the corner. 3a minus b. Because when I lay my palm, it doesn't, at the corner, it doesn't reject, it thought it's a finger. Is that one good? So what would you do next if you have something like this? Try them. Solve for a and b, right? Which I'm pretty sure every one of you know how to solve two equations with two unknowns. It's even linear. Okay, so I claim the following. Let me just write the solution because I'm going to cheat and look at the lecture note. Maybe the lecture note is wrong. I don't know. A is 7/8 and B is 1/8. Okay, good. I cheat, but it works, right? I trust you know how to do that. Okay. Any questions so far, though? Any questions so far? Let me copy this guy a little bit. Let me copy this guy. Okay, let me add the page right next to it before I screw things up. Which means that your solution, your guess for the solution is h of n equals to what? 7/8, 7/8, 3 to the n minus, not minus, plus 1/8 minus 5 to the n. And those are a and b, right? I just plug in a and b. Okay, this thing requires like zero imagination, except you have to guess like I said. Any questions so far? Or any questions so far? So I claim that this solves the equation. But are we sure though? What should we do to make sure that we did the right thing? Let me copy this guy as well. Oops, sorry about it. I screwed up my thing. Right, you should plug in some value and see if you didn't screw up the algebra. There's like 70% chance that you screw up the algebra because there's so much algebra that you need to do. Right? So let's see. Okay, h of 0, okay, is 7/8 plus 1/8. That's clear, it's 1, right? It's 8/8. T of 1 or h of 1 is going to be 21/8 minus 5/8, which comes out to be what, 16/8, which is 2. Aha, kind of work, right? Or you can try more. H of 2 is 7/8 multiplied by 9 plus 1/8 multiplied by 25. 7 times 9 is what, 63? 63 plus 25 is 88/8, which is exactly 11. Looks like magic, right? Or h of 3 is going to be 7/8 multiplied by, okay, this thing is too hard. You just trust me on this one. Minus 5 to the 5. This thing is too hard. Just hope it's 8. You can put it in the calculator. Okay. Any questions so far though? Any questions? Ajahn, you're guessing part. Can you No, no, not really. There are actually a couple of things that you should guess if you learn ODE. There are this guy. There are NA to the N. Only if you have double root and whatnot. But mostly you guess this guy. Just make this guess. And the guess is actually quite well founded. It's because I said that the number of terms actually grows exponentially. So you would expect some exponential growth. That one good? That one good? Any questions so far though? I did this with integer, so you get a rational number at the end. Okay, we're gonna come back to the stair problem. We're gonna come back to the stair problem. There is only one thing in the right ballpark, which is this guy. Just guess this guy. We use the technique that we showed. We didn't really prove, but we show, at least I motivate you that it has to work this way. You can rearrange my argument and make it a proof, but close enough. And we should use the technique that we learned to solve the recurrence with the boundary condition. And someone said the initial value problem, right? Someone over here, Ajahn Jack, right? Ajahn Conrad would be proud. No, Ajahn Conrad teach clean algebra, right? It's Ajahn Jack who teach ODE. Would be proud. Someone said IVP. That made me so proud. I don't know where it is. Someone said IVP. ODE is ordinary differential equation. There's another one which is much harder called PDE, partial differential equation. Much harder. But in real life, PDE is actually quantum, by the way. Quantum is PDE all the way. PDE in real life, you solve it by numerically. You solve it numerically. Risky, you can do it as numerical method project. Okay, so let's take 10 minutes break and we're gonna come back to the stair problem. We're gonna use exactly the same technique and tell you where we got the 1 plus square root 5. Okay, let's take 10 minutes break and that would be 15, 23, 20. Go back to the SN plate. Which one? This one? Right? What, Keith? Exactly. This is something it doesn't require much imagination just to make sure that you do the algebra, right? Any tips to finish 4 tasks of computer programming in 2 hours? The tip is just do the homework. Just delete all your homework and then do it again. I did that every time. I did that. Oh, you did it already, right? I thought Sun told me that the exam is this morning. You should practice first. But if you when you finish the class, you come back and look at the problem for programming one, you're gonna wonder yourself, why did it take you so long? Right? Everyone in data structure can guarantee this to me. Why did it take you so long? Yes, we try though in programming. It's actually, I think I'm right that it's actually not for everyone. Not everyone is. I don't want to say capable, but they do not solve the problem in the way that you write a program. It's especially those who have with a lot of experience, because our brain is sort of wired with a lot of heuristic, right? A lot of shortcut to solve the problem. We know it's there, but we just can't explain it. But now with the computer, which is really dumb, you need to explain every single step to the computer why you make the decision. So some people can't do that. Like we try to teach like adults who is in like unrelated field to think like computer, to think in a way that you write a computer program that you tell it everything exactly, specify the step exactly, right? They can't do it. I don't know why. Yes, you'll thank me later that you take programming. Sorry to butt in. Ajahn, can I confirm the invariant discovered from Pokemon is correct with your after class so that I don't go out of school? If you got what I said earlier about there are three circles that you keep going around, then yes, you're right. Then yes, you are right. if 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 you understand this like sort of Zelda symbol, right? If you understand this picture, then you are correct. Yes, I borrow Zelda. What's the one on Twitter? Breath of the Wild from a student. I I played for 2 hours and then I don't have any time to play anymore. And then when I play it, I see okay, Genshin is a ripoff. Genshin is a ripoff. It made so much money, but still a ripoff. Doesn't have more story though. I play it and then until I got to the Chinese town, whatever it's called, I don't remember the Chinese town. Yeah, Liu. But then there's no story afterwards. So like, come on, this is unfinished. Is there story afterward yet? Okay, good. One chapter, right? Like one chapter afterward. You know, we in Japan. Okay, maybe I should go back and play. But it's really a rip off from Zelda. It's like Zelda with gacha. It's like Zelda with gacha. Oh, which game doesn't require grinding? Airbus, let me introduce you to this game. So this one, Puyo Puyo, doesn't require grinding. Oh, this was right. There was a term when everyone played Puyo Puyo, and then it was on discrete math exam. There are some invariant about the game. use the one in the homework, so I don't need to deal with the factor. Yes, it froze again because I was looking at the homework to make sure that the thing that we proved for the stair doesn't exactly match the homework. The homework is a little bit simpler because of the certain factor. So I matched the homework. So I try to match the one in the homework. It makes your life a lot easier. And even better, I'm gonna do this. Yeah. Really, just just modulo 3 for every single Pokemon, right? You get 3 numbers, right? Just modulo 3. And then whatever you get, keep track of this number. Keep track of this number, you see something. Keep track of all these 3 numbers. Yeah, this is what I meant to do. Just keep track of these 3 numbers, you see something. And if you understand the Zelda thing, not Zelda thing, right? It's more like Genshin, like circle of elements. Then this is what you need to prove, that if you're in here, you come back to there after every move. Okay, so let's do this. Let's do this. Okay, remember that we need to do Fibonacci, right? And then we will solve the problem of that one plus square root 5 over 2. Okay, so let me simplify the problem a little bit. Okay, so instead of proving like f1 equals to 1 and f2 equal to 1 as in the homework, right? This is the stair problem. I'm going to move it back to f0 equal to 0 and f1 equal to 1, and then you can generate the rest, right? So I'm going to call these two my initial condition. But I hope that you see that they generate exactly the same sequence, except it's going to make my life so much easier in solving the algebra. Okay, so far so good. So we hope to solve this recurrence with that initial condition. Some people call it IC for initial condition. Okay, so what do we do? Can anyone tell me? What do we do? If we want to find what is f of n, what do we do? We guess. Yes, GOG mean guess, right? Thanatat. You guess, right? You guess that f of n, f of n is, what do we guess? What do we guess? A to the n, good. Do not guess something else. Guess this. Then you hope, right? Then your goal is to find A. So let's find A. So you have A to the n, right? You find A by plugging this thing in here. A to the n is A to the n minus 1 plus A to the n minus 2. You say, Atan, you see, this equation looks much easier than before. Yes, yes, yes. Yes, yes, yes. It looks much easier, but it doesn't have easy solution, right? What do we do next? Can someone tell me? What do we do next? What do we get rid of? Get rid of A to the n, right? You're gonna get 1 is A to the minus 1 plus a to the minus 2. And then by now you know, right? You multiply by a square on both sides. You're going to get a square is a plus 1, which then you're going to do this. A square minus a minus 1 is 0. What's a, by the way? What's a, by the way? One of them, no, neither one of them. You can plug in 1 or minus 1. It doesn't work. How did you solve this? You still remember something from high school that looks so magical? Did you remember something from high school? How do we solve this? What is a? Okay, that long formula. Okay, minus b plus or minus square root b square. Not even close. Not even close. I like the formula. Square root b plus 2ab over a over 2a. Okay. Quadratic formula. I hope you still sort of see it somewhere in your life before, right? How to solve any quadratic equation, right? Okay, let's plug in the number. So it's a minus. Oh, for AC, yes. So minus b, that's going to be plus 1, right? Plus or minus square root b squared, which is 1, minus 4ac, which is plus 4 over 2, which is exactly that magical number that you see. 1 plus minus square root 5 over 2. So it's not random. And this number, I think either the plus or minus, I don't remember which one. I think the plus one is the name of the number is called golden ratio. Okay, now, would you like the plus or the minus? Right, so that means you have two solutions, right? F of n is 1 plus square root 5 over 2 to the n, or g of n is 1, oops, double tap works, 1 minus square root 5 over 2 to the n. Which one would you like? Both? No, doesn't work, right? You should have one. Pick one. Or tell me why you cannot pick any. Anyone? Which one? Which one do you pick? Or none of them satisfy the base case, right? So for example, f0 has to be 0, like, or both of these when n is 0 is 1. Right? Both of these. When n is 0, f of 0 is 1, g of 0 is 1, but we want f to be 0 when it's 0. So what do? We know that none of them does work. What do we do? What else do we guess? Magic h of n. Good. The linear combination of the solution, right? So we're going to guess that. Actually, let me use another page. I ran out of space. Copy. And sell that. Go away. Oh, the symbol is called Triforce, not Zelda. Zelda is the princess. Now I was thinking, what's the symbol called? Okay, so what is this called? So we guess that h of n equals to a 1 plus square root 5 over 2 to the n plus b 1 minus square root 5 over 2 to the n. Okay, what do we hope hn do? What do we hope it does? What do we hope it does? Oh wait, it do. I don't remember. I'm so bad at grammar. What do we hope it do? It has to satisfy the base case, right? So that means we hope the following, that h of 0 has to be 1. Wait, 1? No, 0. H of 0 has to be 0. 0, and h of 1 needs to be 1, right? So let's plug that in. The reason I pick 0 because I do not have to deal with square root 5. That's why I pick 0. H of 0 is a plus b. Okay, that I love this kind of equation. I don't have to deal with square root 5, right? And then h of 1 is, now you cannot avoid it, right? You cannot avoid it. It's a 1 plus square root 5 over 2. At least I don't have to square. Plus b 1 minus square root 5 over 2 equals to 1. How do we solve this? Can you tell me? What does the top line tell you? What does the top line tell you? A equals to, oh, so close. Okay, good. Good. A equals to minus b. Okay, a equals to minus b, and then I'm going to plug that thing in. So every time I see a, I'm going to replace it with minus b. Minus b, 1 plus square root 5 over 2 plus b, 1 minus square root 5 over 2 equals to 1. What cancel out? Can you tell me? What cancel out? You need to expand it a little bit so you see which one cancel out. Bye bye b. No, no, you've got to solve for b. If b is gone, then we screw, right? We want to solve for b. The chunk, no, they don't really cancel, right? There's a minus sign over here and minus sign is over there. Pull b out. Okay, not a bad idea. Okay, I can pull b out if you, that makes you happy. So b and minus 1 minus square root 5 plus 1 minus square root 5 over 2 equal to 1. Okay, now tell me which one cancel. What do you left with this guy? What do you left with on the left? Wait, did I screw up the minus sign? Did I screw up the minus sign? No, I did not. So that and that cancel, and minus 5 minus 5 square root 5 minus square root 5 is minus 2 square root 5, which cancel with the 2, right? So you would end up with minus square root 5, b is 1, or b is minus 1 over square root 5, and a is going to be 1 over square root 5, right? Which is exactly what you saw in the homework if you practicing back in. Right. So now you know the thing that I asked you to prove in the homework is not magic. Well, every math is magic. You can call it math magic. Now you see, right? Now you see that it's not entirely magical. It comes from a very well motivated math behind it. And you see this a lot though. Okay. There's actually a book though. I think I put a book in 1.5 or 2 called Mathematics or something along that line. You can go take a look. It has a lot of card tricks, some of which I have no idea how to play because I don't understand the instruction. Or I think it's called self-working magic or something. Okay. What about why everyone want me to be your life counselor? You really want to replicate my life? Okay, so any questions so far though? Any questions so far? So if this thing come out in the exam, which it will, it's a free score. No imagination required. Right? No imagination required. Well, the only imagination is the one that I told you that, okay, imagine this guy. Okay. There are also some edge cases, like for example, since we have time, let me talk about it. There are some edge cases. So for example, this guy, What if you end up with something square, then you have one equation, right? Then you're gonna have exactly one solution, right? Then the next guess would be NA to the N. Just as this thing is actually related to physics. If Risky still remember it, this thing is critically damped. This thing is what happened when it critically damped. You guess this guy. This is actually the same thing. It's related. Okay. So I think this kind of thing actually tells you as well that there are two answers for second order differential equation. That actually took me a while to figure out why you guess only two solutions. Okay. Took me a while. Can I go back to H of n? That one. I didn't write a complete one, but you know when you plug it in, it looks like whatever you have in homework. Okay. So this thing is related to ODE. This is actually a more generic form of ODE. And you're going to see this a lot because in algorithm that you're going to learn with Ajahn Kanat and Ajahn Sansan is that most of the algorithm you can't really, it's so hard to compute the complexity. So the best thing you can do is borrow your friend. So when you see a recurrence, right, then you solve for it. You know how to solve for it. Okay, so I think that's all I want to teach you today, because if I start a new one, I'm not going to have enough time to explain to you. Yeah, we're going to start the next one. Wait 2 seconds. Let me check that I teach you everything I need. Don't go yet. Don't go yet. 2 seconds. Let me. Because if I start a new one, then it's going to take a while. Teach you everything that I need. I think I did. I think I did. Yes, I think I did, but the next one gonna take a while. So we're gonna call it a day today. Yes, this is the stair. Know what? This is the stair. Except you put n plus one or something, right? The stair give you this. Know what? The stair gives you this sort of relation. Maybe it's shifted by one and whatnot. Maybe it's shifted by one, right? You know how to solve this recurrence? This guy is a stair. Okay. Any questions so far though? If not, I'm gonna stop recording and I'm gonna be Heat live counselor for 5 minutes. Why is it stop recording? Where's the button? Anyone knows where's the button? Oh, there, stop recording.